Welcome back to the video lecture series for Introduction to the Art of Programming using Scala. We continue talking about case classes, and in this video we're going to talk about how we can use case classes for patterns and pattern matching. So we will write a little Scala code here. I'll just call it patterns.scala. And I want to create a case class that represents a vector in 3 space. So this is something that has an x, a y, and a z value in it. Okay, they're all 3 doubles. And I want to demonstrate how we can do some things here that use this as a pattern. To help with that, we'll write some little functions that do things with this class. So for example, if I want to add 2 of these, v1 is a vect 3D, v2 is a vect 3D, and this returns a vect 3D, which is the sum of those 2. And that is simply the vect, capital V, 3D that has v1.x plus v2, there should be a comma, .x plus v2.x, v1.y plus v2.y, v1.z plus v2.z. Okay, so we just add each component to get a value. Now, how could this be used in pattern matching? We could write other functions, but I'm not going to bother with this at this point, because this is sufficient to illustrate what I want on the pattern matching. So when I call this, let's do val vect1 equals vect 3d of 0.5, comma 2.7, comma minus 0.5. And we'll make a second vector that is something else. Okay. Now we could make a third vector that is just the sum of those 2. So add vect1, vect2. And then when I print this, well, let's say I didn't, and obviously I could do that, but then we just get the normal formatting. Let's run this, make sure that we understand what's going on here. Okay, but what if I don't want that formatting? What if I wanted something else, just the comma separated values? Or what if I wanted it written out with I, J, K, which would be the unit vectors in different directions. Let's just go with the vect3.x plus vect3.y plus vect3.z. I can do that. That will be perfectly happy. But in some situations, maybe you just want the components themselves. You don't care about the fact that it's inside of a vector. You just want to pull out those values. We've done this with tuples. Remember, before learning about case classes, we probably would have defined a vector, a 3D vector, as a tuple of double, double, double. Okay? And then when we would have pulled something out, we would have done something like this. Val x, comma y, comma z equals whatever it was that produced that tuple with x, y, and z. And that would have given them names. In the case of a tuple, this was really helpful because if we didn't give them names like this, it would have been ._1, ._2, ._3, which is very hard to read. But there are some situations, even with a case class, when you still want to do this type of pattern matching. And actually, we can do exactly that with our case classes by using the case class name followed by the argument list as our pattern. And note, these are just 3 variable names. And so when this gets executed, this will create 3 variables here named x, y, and z. And then our print statement would simplify down to this. Now over time, we're going to see more and more uses of patterns like this. But perhaps the one place that would be most useful at this point would be something like a for loop. So if I had a whole bunch of vectors, maybe we could make an array. Vex equals array dot fill. We'll make 100 vectors. That are all random values. Okay. And if I wanted to run through this and do something with the values that were in there, now of course I could say vector v, or I could just say v in vex, except I need to put the appropriate symbol there, and then do whatever it was that we wanted to do with v. But I could also do this to pull out the individual elements, and that way I could give them shorter names, so that instead of being called v.x, v.y, and v.z, they would just be called x, y, and z here. So if you have case classes and you want to pull out certain components, what if all I wanted was the x component? Well, in our pattern match, we can do things like that. Or what if I only wanted to give x its own name, but I did want to have a name for the entire thing? This is one of the more advanced aspects of pattern matching. We can give a name for the whole thing and then an at separated by the thing that we want that name to match. And then we can give variables to only the pieces that we want over here for whatever operation it is that we wanted to do. As I said, we'll see more uses for how this can come in handy. Pattern matching, we'll specifically use pattern matching a lot with the match statements, but a lot of that will wait until the second half of the book.